Welcome back to the demonstration. Continue. Till you design LLD, BRD, HLD, LLD, I strongly recommend you to make use of ChatGPT or Claude Desktop or Google AI Studio, those friendly interfaces. Once your LLD designed, obviously as a developer you have to develop, as a tester you have to test it, as a UI guy you have to build the UI. Go and utilize your Visual Studio Code, Visual Studio or other tools and all. People who are involved in the BRD, HLD, LLD should have good subscription. I have a max license. That's why I don't see any token limit, context limit and all. Have you seen any? No. So many things I'm doing here and there. Of course, it is optimized way, but there is no context limit. Even if I try to see the context now, I will be hardly saying that the 30% utilized. Okay, good. Let us continue. Thanks. For BRD and HLD documents for the business requirement on Nexus HA platform. As a solution architect, now I am required to design low level technical specification document for this requirement, which I would like to include the following key elements in the document. API contract, endpoint, request response structure, error structure, concrete database schema, then how common NFR, non-functional requirements are handled, including logging, authentication, authorization, auth-n, auth-z. These are all the standard terminologies. Auth-n means authentication. Auth means no meaning, whether it's authentication or authorization. Auth-z means authorization. Okay. AAA, authentication, authorization, auditing. Health checks. Open API and Swagger documentation. CORS, rate limiting. Since microservices depend on each other, depend on other services, since some of the microservices depend on other microservices, we would like to add circuit breaker, timeout, retry features. What is a circuit breaker? Service A depends on service 2. Service A depends on service 2. Service 1 depends on service 2. Service 2 not available unfortunately due to some reasons. Assume that there is a third party service. We don't have control over the high availability or failover load balancing. Unfortunately, the service is not available. When the request comes to service 1, obviously we depend on service 2, which they are also going to be failing. Obviously, we also fail, we throw error. 100 requests are coming per second. 100 times you throw error, no? 10,000 requests are coming. 10,000 times you have to throw error, right? Is it a right approach? Is it a right approach? So, approach should be like this. If you find errors more than 5 times within a second, within a particular period like 5 seconds, immediately you should put a break. Next 15 minutes I will not go. I will throw myself error saying that the service unavailable due to some internal server problem. We couldn't be able to process your request. Come back later. Likewise, we will. After 15 minutes, circuit will be opened up to check that whether the different service is available or not. If it is available, we'll open it. Otherwise, we'll once again close it. This should be inbuilt in your service itself, right? This is called NFR. Especially when it comes to dependency services. Next, logging. We already done the logging. Metrics. Collect CPU, network, IO and memory metrics along with HTTP specific, HTTP server specific or service specific. Traces. Both logs, metrics and traces should be OTLP compatible. What is that? Open telemetry protocol. So that I can send the metrics anywhere I wish. Whether you want to support to the Elasticsearch or the Prometheus, the Grafana, Azure Monitor. Because I can't keep on writing specific to Azure Monitor or AWS or Prometheus or Grafana. Should be compatible, something like a standard. You are able to understand. This is for monitoring and observability. Next. If your front-end application connecting to the services directly, assume that we are connecting to authentication services, get the token, storing into the local storage. But people who have got the knowledge can open the developer tools and see the local storage token, right? Possibly they may try to create a fake request. So how do you prevent that? There is a pattern, BFF. Create a backend for front-end. Backend for front-end. Backend generally encapsulates the business logic, backend business logic. But sometimes we create the backend only for the sake of front-end. What for? These features only. CORS, token storage, token refresh. So that front-end always talk to one service, one backend, which behind the scene interact with the several. So why do you want to reveal the backend services to the client application directly? Because when the people see the developer tools, network tab, they can literally see what is really going on. Correct? So how do you hide all this? Able to follow me? Backend for front-end. Suppose if your application is so complex, definitely you have to create micro front-end. Like how we got micro services. Likewise micro front-end architecture also. Then only your UI can be managed. Otherwise, this guy will depend on this guy depends on her, she depending on other people. So how do we make sure that all people develop independently so that they can be integrated? Once again, how to follow micro front-end architecture. Right now, we don't need it because we have only few services. That will complexify the scenario. This is a teacher mentality. What is that? All complex things go to student only. We'll do 1 plus 1, 2. 1 plus 1 equal to 2 only. All the calculus, the kind of examples are given to, or tests given to students. Okay. Next. Error structure should be standard based on, should be standardized based on RFC. If you are throwing error from your microservice, most of the time you will have the gateway, API gateway. Do you want to throw the error as it is what was thrown at the back end to the front end directly? If it is so, what happens? It will have some internal details, something like a sensitive information. So what you are supposed to do is that we throw error, gateway receives it, but how does gateway know that you are throwing error? Because gateway says that JSON going on. If gateway comes to know that there is an error coming, then this guy can transform, store it for auditing, logging purposes, take it to some other error, something like a server error, internal server error, something like that. Or you can control the API gateway saying that include only specific details like one level of stack trace only, not more than that. You can control if you follow RFC standard. If you don't follow, gateway will not know what are you doing actually. Or your program has to understand two things: your service error, gateway error. So that's not a good technique. So that's where error structure should be standardized based on RFC. Next. Draw Mermaid diagrams, how microservices communicate each other, and a dependency graph. Next. All services should be designed with a modular, should be developed, modular design. That means you should not create one file which has got everything. Should be properly separated. See, this is my platform which I built for one of my startups. FAMIs. This particular platform has got so many number of microservices. See there, 45 items. That means approximately 40 microservices. All microservices have been properly designed to such a way that, take an example of service provider management. Open with the code. Do you see that how it has been organized? Archive, docs, logs, script, seeds, SRC folder also now properly organized. API, constant, log, model, schema, services, utils. And the proper files also, env, package.json, readme, troubleshooting. When someone looks at your project structure, when someone opens the project structure, they should feel blissful. Immediately they should not close it. If they close immediately, what does it mean? We are not supposed to follow this way. Most of the time we say, now, who written this code? You should ask the other way. Who written this code? So that I can also follow the same thing. So that's where modular code, modular structure. Anyway, we are going to do that. You literally go to the cloud 9 when you see the project implementation. Right. Do you understand my requirements, thoughts? Ask me question, interview me, asking questions in MCQ formats, which has 4 to 5 options. So I can quickly pick my answers, choices or preferences instead of me writing my answers in prose style. Go. So as much as possible, describe it. For example, how are you going to manage the patient ID? One simple example. How are you going to manage the patient ID? I prefer to have two different distinctions here. One is for internal system purposes. What you can say, the indexing, lookup search purposes one. Then I will have business ID, which is generally used for humans. So one is for system, another one is for humans. That's a good approach. Instead of always, if I give the GUID to the patient who is coming joining, he will die there itself actually. So GUID. Yeah. Architecting round 1 MCQs. So let's see. So instead of repeating this interview me or the asking questions or the don't assume anything, you keep these instructions in the instruction.md file, the one which I have shown, right? There are, in the project level we have sections, instructions, files, chat. Put them in instructions. Automatically it's going to be added to every chat session. Great. I understand exactly what you are after. You are now producing a low-level technical specification for Nexus HA, the engineer-facing companion to HLD, and it needs to nail down the concrete buildable detail, REST API contracts, schema, NFR. Before I draft one efficient note, so I don't waste your students' time. How did I say the students' time? How did you know that? Because yesterday I was talking about, no, I'm teaching to my students. Several of these items are already pinned down by our ADR, self-hosted token based on authentication, single administration role. So it should be okay. Here is the first round for 3 most. That's the answer. Inter-service communication. How should services talk to each other? This drives the circuit breaker retry dependency graph design. Synchronous or asynchronous? For example, service 1 talks to service 2. You want the service 1 to put a message in the Kafka broker and then service 2 pick up and do processing. But most of them we need answers. So synchronous messages only. When do we need message based? For example, I need to notify to my devices. In the appointment scheduling, we do have some notifications. No. When the appointment created, I want to notify the doctor. When the doctor cancels, I want to notify the patient. Such cases, if you do a synchronous mechanism, problem would be you send a message to FCM, Firebase cloud messaging, or APN, Apple push notification. That would take time to reach out to the device. No. Till the time you want to wait. You should not. You should always introduce messaging, asynchronous communication, true asynchronous communication. So the lesson is that whenever you need responses, based on that only I can carry forward. Such cases you have to do synchronous. Whenever there is a humongous amount of traffic between these two services, you should introduce messaging. Otherwise, synchronous communication should be suffice. So here, synchronous REST API communication. Whenever two services talk to each other, don't have to talk in a very standard way. You always switch to gRPC, which is more performance centric. But if that service is differently located, for example, initially they were all in the same room, suddenly moved to some other places. One is running in cloud 1, another one is running in cloud 2. that time you will have a problem. So you have to be very cautious about that kind of choices. So let me choose the synchronous REST API between services. BFF edge topology. How should clients reach services? Single shared BFF for both web and mobile. Yes. Identifier strategy. Now see there. What should be the primary keys look like in the concrete schema? Let's now give that. So whatever the option given to me not satisfying. For system internal references, we shall use GUID, unique identifier, sequential ID, and for patients, doctors, we shall use human friendly identifier. For example, PAT 2026 BLR 00012, DOC 2026 BLR sequential ID for the entire entire column. Okay, that's fine. That's fine. That's fine. That should be fine. Next. Two of these are pragmatic. All three carry consequences worth putting on record. Synchronous rest between services, fine at this scale, but it is why your resilience requirements are not optional. Right now, okay, at this scale, but once you go to the bigger scale, this is not ideal. It is okay, fine. A single shared BFF sensible with one watch point. The textbook reason BFF exists is the per client optimization mobile, because Flipkart web application has a different backend, Flipkart mobile application has a different backend. Why? Because the way you render the contents in the mobile devices far less and optimized and performant compared to the Flipkart web. That's why most of the times you see more offers in the Flipkart mobiles only than the Flipkart web. They encourage you to always use mobile. Okay, so that's what he's saying. Do you want to have something like a BFF specific to web and the BFF specific to mobile? Right now we are not complicating the whole scenario. We are developing only simple things. So we okay, perfectly all right. Your identifier schema is good, dual key pattern, but the branch code embedded in it needs a clear rule. You only told one doctor can belong to multiple branches. Then if you add branch name like a BLR, what happens? So we can assume like this. The doctor when it is onboarded, that is a branch. So this is called business decisions. Okay, so error structure RFC 9457 problem details, latest obsoletes 7807. So in the morning section, it was prompting me to use 7807. Now this is recommending saying that hey, 7807 is something like a old standard. Better is to something like a 9457. If you are still not very sure about that, you go on to do some research like this. Now this should be fine. The key differences: official status, format flexibility. While RFC 7807 heavily focus on JSON, RPC, XML, HTML. INA registry. RFC 9457 establishes a format INA registry, hosts common standardized problem type URIs, extensible and clarity. So based on the latest standards, it says that better to use 9457 published in July 2023. Obsoletes 7807. Most likely this may be 2020 or 2019, that standard. API versioning. API V1 is a right versioning. You should not be based on the header and all. Those are all pretty old style. It should always be API / V1. Rate limiting. Fixed window at the BFF edge, ideally speaking. For now, we can agree upon IP based 100 requests per minute per service. And by default it is disabled. Oh, that is fine right now. That is the technical implementation plan. By default, when in the development phase, you should not have the rate limiting and all. Should be disabled. Once it goes to production, it should be enabled. Okay, we answered some questions. Another 5 minutes, we'll complete this LLD. Once it is initialized, it will be generating. By the time we return back, it will have been ready. Audit write mechanism. Given everything else is synchronous, how should audit entries be captured? It is an additional activity that we are going to be dumping into some table. So synchronous call to audit service each write. So it's an additional latency cost. Or transactional outbox async to audit. That means we write it, but asynchronously we are going to write it in the audit. So when you do the transaction, the auditing is not going to be transactional part. Oh no, it has a consequence. For example, during the transactional action, asynchronously we are auditing, rollback happened. What about auditing? That has made, we already made an asynchronous call, no? So ideal choice would be hybrid. What is that? Whenever you have a non-sensitive, non-mission critical, such cases asynchronous. Mission critical, always synchronous. That choice should be made in that way. So synchronous call to audit upon each write, that is fine. This is simple, consistent, coupled. Observability backend, hotel, collector, Prometheus, tempo, eager, traces, Loki, sequence, logs. That should be perfectly all right. Soft delete 30-day purge. Status equal to archived, archived at timestamp, scheduled job purges after 30 days. You're right. As per the DPDP Act, you must allow the people, you must allow the system to completely erase if it is not going to be useful to your business at all. So that is one of the requirement. And there is a consent also. For example, when you're registering patient information in the system, there should be a consent. Suppose if you're registering the child specific information in the system, your application should not use those data for target audiencing for ads and all. Those are all part of the DPDP Act. You are able to understand. So you can ask this kind of questions to saying that what are the things I should follow. Right. So once all the questions are finalized, we'll just initiate to create the LLD. So the point here is that Once the LLD document created, you can easily give it to the developer who can build, create the test cases for testers, and UI people will be able to design user interfaces. Of course, in the demonstration, I'm going to do one by one only. But in your live, in your environment, you can parallelize. So last question I'm going to ask. What are all the contents, what are all the elements, what are the sections you're going to be having in the LLD? So that once I'm clarified, we are good to go ahead with the drafting. Audit failure policy. If the synchronous audit write fails, what should happen? Fail closed, block the write if it cannot be audited. Complaint safe. Fail open, allow write, reconcile, audit later. Availability safe. Fail closed, but with a durable local fallback, log into reconcile. Not sure. So how auditing is important to you? Okay, so that's where the point is at. Suppose if I'm not able to write in the audit, do you want the transaction also to fail? So I will say that fail, open, allow the write, reconcile, audit later. Defaults and drafting. Shall I proceed with the approved? Apply the defaults and draft the LLD. Approve, but I will override the defaults. So can you tell me what are all the sections going to be present in the LLD? I would like to review and approve before you proceed to drafting. See, this is where you have to introduce the messaging. Auditing, I want the auditing to be guaranteed written, but I don't want that right to happen completely. So what you can do, you can just push messages to the Kafka broker, and then the audit service automatically can pick up and start writing the audit. That way, you are not having the performance related issues, at the same time guaranteed to be available in the auditing. Noted. File open. Propose the LLD structure for Nexus HA. Okay, so let us now add Health Assist logo to the document. Okay, Health Assist logo, images. We are going to use this. Copy image, paste it. LLD outline. Happy for me? Yes. Can you use the attached? Can you use the attached image to add into the LLD document in the front page? I don't see one in our conversation. Found it. Let me look at the image so I know how to place it. From where did you get it? Check the uploaded image file. Okay. Now we are not very sure whether it is going to produce a markdown or Word document. We are not very sure about. Why do you want to take a time wasted? So just logo drafting. Shall I add the logo to the title page and draft the logo as? Yes, logo on the title page, draft the LLD now. Yes, logo on the title page, draft the LLD. Now make sure that you produce markdown file format document. That's it. So once it starts generating now, we can go ahead with the coffee break. All right. I think it is doing the work. We'll now we'll start the coffee break.